we're going to solve rational equations. So now instead of all these operations with expressions, we put an equal sign in there, so now it's an equation. Now the idea of an equation is that everything about the equation on the left side and the right side has to be equal. So if I've got one fraction that's x over 6, and I got another fraction that is 1 over 6 plus 5 over 6 without doing any sort of solving, just kind of thinking logically, you can probably tell me what the answer is for x. Because when I add fractions, I'm just going to add the numerators together to get this 5. So x plus 1 equals 5, so x has got to be 4. Now, if they're not common denominators, like 4 and 7, and I'm going to make that a fraction over 1, I'm going to make them all common. And the idea is I'm going to make them all common because now, and I'm being a little bit, I don't know what you want to say, picky on the 4 times the 7. I'm basically making my common denominator 28. So now I've got 7x over 28, and I've got, forgot that 4, 12 over 28 is equal to 28 over 28. So all of these are over 28. That means that I can just solve that numerator. So 7x plus 12 equals 28. So I do my little algebra. 7x is equal to what? 16. X is equal to 16 over 7. Okay, kind of an ugly answer. They're not all going to work out that way, but you get the idea. Here we go. Let's try another one here with a little bit more to it. So I need to make them all the same denominator. So I'm looking, I've got an x and a 2. So I'm going to make them all a common denominator of 2x. So my first fraction already has the x, and I'm going to multiply it by 2. X and 2. So 6 minus x is equal to 24. And it's all over 2x, 2x, and 2x. So if they're all over 2x, that means 6 minus x is equal to 24 is my possibility. So I'll subtract 6, negative x is equal to what? 18, divide by negative 1, so x is equal to negative 18. And there's my answer, maybe. Now I got to worry about is restrictions. Basically, what numbers will make this fraction turn into 0? And that number is 0. So x cannot be equal to 0. That's the one answer I can't get. So 18 should be good to go, or negative 18. Okay, let's try that again. Again, I'm trying to find a common denominator. Looks like it is x plus 1. Make that a fraction. Now, the only one that doesn't have x plus 1 is this 4. So 5x equals 4 parentheses x minus 1 minus 5. And distribute there. So 5x is equal to 4x minus 9. Now this is just everything you would have done solving before. And now my restrictions, again, I can't get 0 in the denominator, so it's x plus 1 is equal to 0. Solve for x, and x cannot be negative 1. But negative 9 is not negative 1, so negative 9 should work as my answer. Okay, similar concept. The only thing is this one here can be factored, and I'm going to factor it first before I decide my common factor. And this doesn't have either one of those. But this first one has x minus 2. The second fraction has x minus 2, also with an x plus 2. And the last fraction is just a 1. So I'm going to multiply this first one by x plus 2. I'm going to multiply my last fraction by both of those. Okay, over here I'm going to have to FOIL, so I'll take 3x squared minus 2x plus 6x minus 4. Okay, all over x squared minus 4. I don't need to put that again. Remember, I'm just trying to get the numerators the same. Okay, equals, and then the 6. And if I FOIL out the x minus 2 and x plus 2, I'm pretty sure it's x squared minus 4. So I'll do a little combining like terms. It looks like I got a quadratic, so I'm going to solve by factoring or the quadratic formula, but either way I gotta get all of my other stuff moved over to the left-hand side. So it's equal to 0. Greatest common factor is 2, so I'll take that out. And if I come up here, I got x squared plus 2x minus a 5. Are there factors of 5 that add up to be 2? Nope. So I'm going to have to go to the quadratic formula. So I'll go minus 2 plus or minus the square root of 2 squared minus 4 times 1 times negative 5 all over 2 times 1. So underneath here, right there, I got, 4 plus 20, so 24. Do a little bit of factor tree action with that, and I get a 4 and a 6. So negative 2 plus or minus 2 square roots of 6. I got that 2 out on the outside because of those 2, all over 2. I'm going to reduce that down a little bit and get x is equal to negative 1 plus or minus the square root of 6. Okay. Now my restrictions, again, my denominator can't be equal to 0, so x minus 2 equals 0, so x can't be 2. And x plus 2 equals 0, that means that x can't be negative 2, which my answer wasn't, so we should be good to go. Okay. Similar idea. There is one thing you can do when it's just a fraction equal to another fraction. You can do what's called, I don't know, you probably remember this, but from geometry, but you can cross multiply. So I can multiply those two together, so 1 times x squared plus 4x, and set them equal to this product of 3 times x plus 4. Okay, so I've got x squared plus 4x is equal to 3x plus 12. Same thing, I'll have to subtract 3x, get this equal to 0, since it's a quadratic. And I've got x squared plus x minus 12. But unlike the other one, this one's factorable. So plus 4 and a minus 3. So I'll set those both equal to 0 and solve for x. So x could be negative 4 or x could be positive 3. Okay, but I need to set my fractions equal to 0 and solve for the restrictions. So I'll take out an x from here, and I've got x plus 4. So my two restrictions are x can't be 0 and x can't be negative 4. So that means, going back to my original factoring, this guy right here can't be used. Okay, why? Because it's going to make my denominator turn to 0. So that is my only solution to that guy. So that's solving by, or solving rational equations. You can either do cross product, but that's only when it's a fraction equal to a fraction. I'm going to go back through these. Here I can't do it because it's not a fraction equal to a fraction. Couldn't do it on example 1. Couldn't do it on example 2. But hopefully this helps.